Professor Spectrum, experts in spectral technology.
Welcome back to Professor Spectrum. I'm Sophie Sharoni and I'm a spectral analyst at Portable Spectral Services.
And I'm Naomi Potter and I'm a spectral geologist. So today we're going to look at some of Google's most asked questions about FTIR.
So here at Portable Spectral Services we have a benchtop FTIR unit. It is a Bruker Alpha 2. It comes with a range of different attachments, which is fantastic for analysing a range of different sample types, so solids, liquids, gases, that sort of thing. So let's get started. All right.
What is FTIR spectroscopy?
Right, so FTIR spectroscopy. So FTIR stands for Fourier-transform infrared. So it's a type of light technique where you have the full range of the light spectrum that is directed down to a sample. The spectra you get at the end can be in either absorption or transmittance, though fundamentally they tell you the same thing. So the light that is emitted by the FTIR instrument basically interacts with the bonds in the sample, so we're getting structural information about the compounds or minerals that are actually in our sample. So there are different types of methods of analysing with FTIR, so some of the common ones that are known about are either just sort of direct reflectance, but you also have ATR, so attenuated total reflection, or you also have drift.
Is FTIR qualitative or quantitative?
Okay, so it is actually commonly used for both. So it's fantastic as a qualitative technique for really just identifying a compound. It's particularly commonly used in organics as well, as all the peaks are going to be characteristic to a specific compound. So you can use spectral matching, or you can use actually just look at the peaks and do some peak peaking. But one of the great things about FTIR is that it is quantitative. So thank you to Beer's law, which means that the height of the peaks is actually directly proportional to the concentration of that actual compound. So by developing a calibration curve, we can actually use it to quantify certain compounds or minerals within our samples, which is very, very useful.
Is FTIR destructive?
No, it's not fundamentally a destructive technique, so you don't destroy your sample by actively analysing it. In some ways it can be considered destructive in the sense that, particularly for a lot of the time the quantitative analysis, you might need to homogenise your sample. So in terms of mineralogy, you might need to actually have your pulverised sample, which is fundamentally destructive to the original sample. But there are techniques if you do have to preserve the integrity. So things like the front reflectance, that is fantastic for non-destructive analysis because you don't have to effectively grind your sample down. ATR can be non-destructive on sort of more like documents and things like that with regards to minerals because of the contact pressure required and the small sample area. You really need that homogeneous sample for it to a pulp effectively. So yes and no, but fundamentally the technique doesn't actually destroy it as it analyses.
So you mentioned using the FTIR on documents. So does it have a wide range of applications?
Yeah, so Portable Spectral Services does do most of its work in the mining industry, but actually in-house we have done experiments on looking at the different types of pigments and papers. So we actually have someone in-house who's currently doing a research project and looking at how we can compare pigments on different documents to look back at how those are related to certain period pieces. So it's absolutely not totally constricted to the world of mineralogy and geology. So it's got quite a broad range of applications. I personally have used it for looking at organics as well. It can also be used for in the pharmaceutical industry for positive drug identification for impurities and actually just qualitative analysis as well.
Is there a certain type of material that you have to present for the different techniques? So, if you have a pulp sample, can you only use certain types of FTIR spectroscopy and vice versa with crystals?
Yeah, so because there are different sort of ways of analysing with FTIR, so as I mentioned, you've got sort of your ATR technique, you've got your front reflectance, you've got your drift. So ATR is quite flexible. You can absolutely use liquids and solids. So you just need to have good pressure. Actually, with it sort of works off a diamond crystal effectively for its absorption interface. So yeah, you can use both pulps and liquids. In some cases, if you do have the right setup, you can actually also analyse gases with FTIR as well. So one of the things that you do have to consider as well is that because you can, to some degree, analyse gases, things like carbon dioxide and water in the atmosphere, which do have bonds that are active to FTIR instrumentation, will appear actually in your spectra as well. So you do sort of have to be careful of those contaminants if you don't actually want those present within your data as well.
Can FTIR detect metals?
No. So one of the fundamental principles about FTIR analysis is that you have to have that bond that can create a dipole moment within the sample itself.
Yep.
So the way that the elements are bonded in just a pure metal kind of substrate means that you're not really going to get any of those characteristic signals appearing in your spectra. So it's not going to be very informative. So unfortunately, no. Portable XRF instrumentation, however, would be perfect for identifying your metals. That's definitely more the route you'd want to go down. Yeah.
How to read FTIR?
Right, so when it comes to reading your spectrum, you sort of need to look at the peaks. So the different peaks in the spectrum, of course, relate to the characteristic bonds within the compound itself. So you can either do it sort of manually, where you identify all your different peaks and you can go through literature to see what's characteristic for a certain compound you're looking at. Or another thing that's used particularly in just the qualitative analysis side is actually building effectively a library. So take a whole range of substrates that you have known composition, that you know, and that's what you're looking for, create a library, and you can effectively use spectral matching to identify what's actually in the spectrum itself. So thanks for watching. I'm Sophie.
I'm Naomi.
And we'll